Hey, I'm Adam, your math coach. Let's have a look at this SAT question. Let f of x equal a times x squared and g of x equal b times x to the fourth power for any value of x. If a and b are positive constants, for how many values of x is f of x equal to g of x? 1, 2, 3, or 4. If you want to give this problem a try, pause the video. And now let's see how we can solve it. So we have to have f of x equal g of x. Two function. Okay, we would like to graph the functions because solving them would be difficult. So we would like to graph them. We would like to have a coordinate system with x and y. And we would like to do this. So, okay. When does two functions equal to each other? Well, if we graph them, let's say we have functions like this, and we have a function like this. They would be equal if and only if they have an intersection. They intersect each other. Okay, so how can we use that for our advantage? So, what do we know? A times x squared. This would be, so our typical x squared function would look like something like this. No, something not like that. Actually, something like that is on the, if x is 0, y is 0. Okay, if we multiply with something, what would happen? Well, it would stretch. It would be to have a steeper loop. It would be steeper. And because we know that a and b are positive, it won't turn upside down. So it would be facing upwards. Okay, so sketch it here. Something like that. That should be good. Okay, what do we know about b of what do we know about the x to the fourth power? Well, let's see. We can see that if we have values that is less than 1, aka 1/2, that would be when we raise 1/2 to the fourth power, that would actually be less than raised to the second power. And that is for any value that is less than 1. I mean less than 1 but greater than 0. So if x is less than x, the absolute value of x. So let's say it's 1, it's negative, and it's 1. If x in this region, our x value, our y value for the function, for the x to the fourth power, would be less than x to the second power. So if we just have, okay, so if we would start graphing our x to the fourth function, which is also would look in this direction because b is positive, it would start under the r x to the second power function. We can also see that if x is 0, they would be equal. That would be 1 point they are equal. And well, we actually know it's easy to see if we have a value greater than 1, then x to the fourth power would be greater than x to the second power. But then, what happens at 1? Well, if x is 1, then they are both 1. And if x is negative 1, they are actually also both 1, because they are negative 1 is raised to an even power. So if we were to graph we actually know our answer already, but if we were to graph our x to the fourth power function, this would look like something like this. So if the absolute value of x is less than 1, then x to the fourth power would be less than x to the second power. And if the absolute value of x is greater than 1, so here and here, x to the fourth power would be greater than x to the second power. And at negative 1 and at 1, and also at 0, we have contact points, intersections. So there are 3 values where these two functions equal to each other. Well, that is when we say that a is 1 and b is 1. If a is 1, a isn't 1 and b isn't 1, then it wouldn't be at points 1 and negative 1, but there would be 3 points also. So just for easy understanding, I showed this, but actually they could look like something like this, where this is one contact point and this and this. It could be like negative the third root of 3 and third root of 3 or something, but there will always be 3 intersections. Yeah, so that's it. I hope you managed to solve it, and if you want to see more problems like this, check out my other videos, and thank you for watching.